There are 40 dots on this card. When we show this to one of our tiny children, he says 40, 40, 40. We adults are deceived by what we think we are supposed to see. Tiny children are not. It fascinates me that virtually everybody hates math, and everybody feels incompetent in math. And yet math is a language, a very simple, straightforward, logical language. Let's take these little calculators. I hate these things. I say to this calculator, which is worth $4 worth of plastic, tell me, what is 987 times 654? Push the equal sign, 645,498. That infuriates me. I'm a human being with a human brain. I speak a language that is infinitely more complex than this language. You know, English has a minimum of 500,000 words. A splendid vocabulary is 100,000 words. And we people speak our native tongue without the slightest problem of any sort. Then we come to a language that has 10 words. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And we cannot speak this language of math. You know, all the computers in the world hooked together could not carry on a truly free-flowing conversation at a 2-year-old level. And we human beings do, or 2 languages, or 7. And here, this tiny thing speaks math, and we can't speak math. This led us to great problems in trying to figure out why we people can't speak math. At least in theory, you should be able to say to me, what are the mathematical problems involved in getting to Mars? And I should be able to answer a complex philosophical question, and I cannot. What does it mean? Let's go to a brief summary of how to teach a baby math. The question should not be, how is it possible for infants to do instant math? But rather, how is it possible for adults who speak a language not to do instant math? The problem is that in math, we have mixed the symbol 5 up with the fact 5. When the problem is on the order of 5, or the reality of 5, it's not a problem, since the adult can perceive either the numeral 5 or the reality 5. Indeed, a perceptive adult can perceive the symbol or the fact successfully from 1 up to about, with some degree of reliability, from 2. The reliability of even the most perceptive adult tends to descend sharply from upward. 1 is guessing, and almost invariably guessing very badly indeed. Children who have already been taught symbols, which is to say the numerals such as 5, 7, 10, or 13, but do not know the reality of 5, 7, 10, or 13, are almost completely unable to do instant math. Tiny children, however, see things precisely as they are, while we adults tend to see things as we believe them to be, or as we believe they should be. I find it maddening that while I completely understand how tiny children can do instant math, that I am unable to do the same thing. The reason I can't is that if you say 79 to me, I am not able to see, which is the truth of what I think of as 79. It isn't precisely true to say that I can't see it. I can see it, but I cannot perceive it. Tiny children can. In order for tiny children to perceive the truth of 1, which is actually, all we need to do is say this is called 1, showing the child the card. Next we say this is called 2. Then we say this is called 3, showing the child a card with 3 dots, and so on. We need to present each of these only a very small number of times for the child to know and remember them.